Okay, folks, section 13.1, fractional exponents. I think this is going to make complete and easy sense to you guys once we get going. But exponents can be fractions. They can be whole numbers. They can be negative integers. They can be fractions. Okay, so let's look at this. This one says solve 4n times 4n times 4n. Remember, if I did 4 to the third, let me get that out of the way. If I did 4 to the third times 4 to the third, I would just add the exponents, right? That's 4 to the 3 plus 3, which is equal to 4 to the 6th, okay? Okay, well, let's do this. This is also equal to 4 to the n plus n plus n. And instead of repeated addition, I would just say, well, that's equal to 4 to the 3n. Okay? So I just want to practice that, get that idea back in our head that if we have a base, the same base, we just add exponents. All right? And I want you to keep that in mind because that's going to help us when we're dealing with these fractional exponents. Okay? Okay, let's look at the next example. On the next example, it says, write each of the following radicals in exponential form. Now, something that you don't know necessarily is that square roots or any kind of roots are actually written as a fraction. So the square root of 5 is actually written as 5 to the half root, or to the half, 5 to the 1/2 power, okay? You'll see that this is a 2 right there, square root. That's what I put in the denominator of the fraction. For b, this is going to be, it says cube root of 7, so that's 7 to the 1/3, right? 3, 3, okay? Here in c, the fifth root, here I need more root now. The fifth root of 2, well, that's 2 to the 1/5. It's saying what number multiplied by itself 5 times gives me 2. But remember, fifth root, the root goes in the denominator, okay? And then d, we're going to get the seventh root of -12. Now that's possible because this is an odd root. If it were an even root, then we couldn't take that of a negative number. We'll talk about that in the next lesson about imaginary numbers. But this is just going to be -12 in parentheses because I want to say this negative is also being raised to this power to the 1/7. That's it. Done. Piece of cake. Okay? All right. Now, let's talk about why that's true for a moment. Okay? Let's go back to the square root of 5. That's a simple one. Let me erase this for a second. Because I just want to talk about how do we know that that's true, Mr. C? Well, let's say I've got 5 to the n power, okay, times 5 to the n power, okay. Let's say that equals 5 to the first, right? Okay. Well, let's keep working with that for a moment. Do you agree that if that's true, then 5 to the n times 5 to the n, that's 5 to the 2n, right, is equal to 5 to the first. So 5 raised to this exponent is equal to 5 raised to that exponent. So that means that those two things have to be the same. If we've raised 5 to this is the same as 5 to that, that means that 2n has got to equal 1, right? Okay. Well, let's divide both sides by 2, and that means that n is equal to 1/2, right? What that means is that this number is the same as this number. What number multiplied by itself is equal to 5? Well, 5 to the 1/2, right? Also known as the square root of 5. That's where it comes from. That's how we know that this exponent can be a fraction. That's how we know we can write it as a fraction. Okay? Nice. I feel like I explained that pretty well. All right, let's keep going. Let's look at the next one. 49 to the 1/2. Well, that means what number multiplied by itself twice gives us 49? Well, that's easy. 7, right? Square root of 49. This is cube root of 64. That means what number multiplied by itself 3 times equals 64? Okay? Now, you can put this into your calculator if you don't happen to know it, but you can enter it into your calculator as 64, up arrow, parentheses, 1 divided by 3. Done. And the answer is 4. 4 times 4 times 4 equals 64. Okay? Now, I'm going to actually erase this just so I have some room for C. Now, can I find the fifth root of a negative number? Sure, because it's an odd root. I can have odd roots of negatives, okay? Because think about this for a moment. Negative 2 times negative 2 times negative 2, right, is equal to negative 8. And if I take the cube root, right, or the third root of negative 8, yeah, that has a real answer, negative 2. Now the square root of negative 8, can't do that. Square root of negative 8, this, no solution, okay? Because I can't, there aren't two numbers multiplied together that give me a negative, but three numbers can multiply together and give me a negative, okay? All right, well, that's okay. We're saying we can find this. If you don't happen to know that it's negative 2, the answer, you can type in negative 32, up arrow, parentheses, 1 divided by 5, and hit enter. Done. Negative 2. Okay? Oh, now look at D. We were just talking about this. The even root of a negative number, no real solutions. Tomorrow, we're going to talk about solutions to this, but they are imaginary. They're not real solutions. Okay? Those terms are misnomers. Okay? I mean, it's something real to work with, but it's not a part of the real number system. Okay? All right, let's look at the next one. Good job. You've worked with your first fractional exponents. You know what they mean. Okay? It says you know that the cube root of 7 is equal to 7 to the 1/3. How would you write the cube root of 7 squared in exponential form? Well, if the rule of exponents for a power of a power is to be true for all positive exponents, then the cube root, and I'm right here, the cube root of 7 squared is equal to 7 to the 1/3 squared, which is equal to 7, well, I don't know what, 7 to the 1/3 times 2, which is equal to 7 to the 2/3. Think about this. It's saying 7 to the 1/3 times 7 to the 1/3, right? We're squaring it. That times itself. What do we do to the exponents? We add them. 1/3 plus 1/3, which is equal to 2/3. We don't have to add them. We could multiply it by 2, which is what they did here. Okay? So, what happens is the exponent always goes in the numerator, and the root always goes in the denominator. Okay? So, let's look at these examples. Easy stuff here, okay? Think about this. This is the cube root of 5, right? Squared, well, that's just 2 times 1/3, which is 5 to the 2/3. Remember, exponents that are separated by parentheses get multiplied. Square root of 6, that's the same as 6 to the 1/2. To the 5th, that's 6 to the 5/2. Leave it as an improper fraction, please, okay? Let's see, this next one, it said write each of the following radicals in exponential form. I'll do this next one in red, right? It's easy. To the 1/5, 2 to the 1/5 cube, that's 2 to the 3/5. Okay? I could find out what number multiplied by itself 5 times equals 2, and then I could raise it to the 3rd power. Okay? Here, 10 to the 5th, okay? I'm sorry, 10 to the 1/5 raised up to the 4th power is going to be 10 to the 4/5. Okay? Nice. We're getting there. We're getting there. It's the next example that I'm excited about. All right? Let's look at this. Now, they want us to actually simplify these things. Okay, well, let's look at this first one. The first one says 4 to the 3/2. I like separating these things. I think it helps me. Okay, so I'm going to write 4 to the 1/2, right? Cube. I just took the 3 and put it outside of the parentheses. Well, what's the square root of 4? 2 cube, 8, done. 4 to the 3/2 power equals 8. Nice. Okay, same thing here. 32 to the 1/5 raised to the 4th. Well, what's the 5th root of 32? We did it a minute ago. Well, we did the fifth root of negative 32 was negative 2. So the fifth root of positive 32 is going to be 2. To the fourth? Well, 2 to the fourth is 16. Done. Done. Man, that's nice. Love that. Okay, negative 27 to the 1/3. I'm going to have to put brackets around this. Okay, square. What is negative 27 to the 1/3? What number multiplied by itself 3 times gives me negative 27? Well, you can punch that into your calculator if you want, but you should know that it's negative 3. Squared? 9. That easy. That easy. Last one here. This is negative 16, right, to the 1/2. And then I'm going to raise that to the 5th power. Whoa, whoa, square root, negative number, no solution. No real solution. I'm starting to write that now, and so are you, because we know that it could be a complex number that would be a solution, or an imaginary number. All right? All right, I think you got the idea, guys. This is easy stuff, but conceptually, I think it's just something you hadn't really thought about before, but now I think you can see how easy it is. Okay? That's it. You're ready, and I'll see you tomorrow.